I'm Dr. Anita Warrier, Professor, Department of Physics. So today we are going to start this course on nanotechnology, and this journey will be from the nano world into the meta world. This universe, as you know, is made up of two different aspects, that is matter and the energy. The matter part of it comprises all the science you learn about materials. And matter, if you look at it, it's basically made up of small units which we call as atoms, and atoms which are further made up of the nucleus and the surrounding electrons, and the nucleus comprising the protons and the neutrons. The most of the properties of the materials that you see in this universe is basically because of the electrons and how they interact with the electrons from other atoms. So this interaction between the atoms and between the electrons gives rise to the entire properties of this universe. Now, when we are going to put up electrons together and the atoms together, the electrons occupy various positions. The electrons take different levels, which we call as a K shell, L shell, M shell, and an N shell. This is how an individual atom looks like. So you have your central nucleus made up of neutrons, protons, and various energy levels which are filled with electrons. And these electrons are not filled just randomly. They follow a particular rule called as the Pauli's exclusion principle, which states that no two electrons which are entirely identical can occupy the same level. So based on this, the electrons are occupying multiple levels. And these each levels have a set energy to them, and we call them as the energy levels. This is the case of an individual atom. But a solid is made up of many atoms, millions of atoms put together makes your solid. When these atoms join together, the energy levels from a single level become double levels, or they become triple levels, and finally, as it is a solid made up of infinitely large number of atoms, it becomes a band. And how the valence electrons in these bands decide the property of your material. If these bands, the existence of electrons is rather free, the electrons are able to move from one level to the another quite easily without taking up much energy. We call them as metals. Here we can see the electrons. There is no classification between the valence band and conduction band, which seems to be existing as a single band, or that we can say the valence band and the conduction band overlap with each other. If the valence band and conduction band looks much separated, valence band is the band where the electrons are tightly bound to the nucleus and they are not longer free. Now, if from this valence band the electrons are able to move to the next band, conduction band, where the electrons are free to move, if this transition is possible by supplying a small amount of energy, such as a light energy, a little bit of electrical energy, or even thermal energy, we call them as semiconductors. And if to make this transition, you need to supply lots of energy, which are too high to even imagine, like energy higher than 5 electron volt, we call them as insulators. This three classification: the first class of metals where the energy bands are overlapping, the second class for the transition you require a small amount of energy, and the third one, the insulators, where you require a large amount of energy to make this transition, gives rise to largely varying properties of these three classes of material and their application. And the amount of energy that has to be supplied to make an electron jump from the valence band to the conduction band so that they are free, we call them as the energy band or the band gap. If you look at the applications of these three classes of material, the insulators, where the energy band is much higher, are used for multiple purposes, like for thermally insulating, for electrical insulation, for thermal protection, etc. The second class of materials, called semiconductors, are widely used in electronic industries for making of various integrated circuits and other components. And metals, as we know, are ruling the industry because of their highly conductive nature. So with that, we come to the end of this session. We'll continue with nanotechnology in the next session. Thank you.